and that was a bummer. All right, Jed, you're not driving, are you? I hope you're a passenger.
Nope.
Okay, good.
Pulling into a driveway.
You're pulling into a driveway?
Yeah, I just had to run around the corner. Sorry, I know you take attendance. I've been watching the road though, don't worry.
Okay, well, I don't like people crashing in my class, so I want you to be safe.
You got it.
All right. Okay, so we're going to start on chapter 4 today. We're going to talk about scatter diagrams and correlation. So a scatter diagram or a scatter plot is known as, it's a graph that shows the relationship between two variables, and or visual representation. We try to put the explanatory variable on the x-axis, and sometimes that's a little harder than it looks, but you got the explanatory variable usually on the x-axis, the response variable on the y-axis. And this is kind of an exploratory step to see if there's any relationship between two variables. If there is, then we start looking for just regression, which we'll cover tomorrow probably. So, wow, I normally show how to do this in Google or in Excel, and I'll probably do that again today, but I guess you guys get to do this by hand. The idea is we're going to look for striking deviations from the pattern. Is it a strong relationship? Are the dots close together? And is it a positive or negative relationship? So let me go ahead and open up a spreadsheet. So let's see here. All right, so I'm going to pull up this spreadsheet, worksheet 4.1. And okay, so a golfer has chosen to swing the ball on a 70-degree day with no wind. We want to see if there's a relationship between club head speed and the distance in the yards. So first question is, do you all think that there might be a relationship between club head speed and how far the ball goes? Yeah, that seems like a reasonable relationship, okay? So the idea here is, so I'm going to cheat and I'm going to do a scatter plot first in Excel. And so I'm going to go insert, and then they've got this little scatter plot diagram, and we're going to do that because that's going to be quick and easier than drawing it. But you guys will get to draw this by hand, lucky you. So, of course, any good graph, we should add axis titles. So, what should I put here? Let's pick on Anna. What should I label this x-axis here?
The club head speed.
Okay, club head speed. So the club head speed and the vertical axis title?
Distance in yards.
Okay. And maybe what are the units for the club head speed?
Miles per hour.
Yes, miles per hour. Okay. All right. So, and maybe for the title, what should we put for a title, Hayden?
Sorry, I was muted. Probably the distance that the ball, or distance of golf balls hit.
Okay, so, well, we've already got distance here. I'd probably put 70-degree day, no wind, golf club swing. Okay, something like that. All right, now the idea here is, here, let me go back to my notes for a minute. It looks like we could probably draw a straight line through this roughly, right? So we're trying to see how strong the association is, and for that we're going to calculate the correlation coefficient. And I'll show you how to do that in just a minute. Correlation always falls between a -1 and +1. But close to 1 or -1 indicates strong correlation. Close to 0 often indicates no correlation. And then we're looking for positive or negative correlation. So kind of what we're looking for, this is, you can view this scatter plot as kind of a hot dog shape, right? You could draw a straight line through here pretty easily. So this would indicate a pretty good correlation. This here, there's no real pattern going on. This would be an example of what we call a null plot. Whoever came up with this must have been hungry, because we call this the hot dog, the hamburger, and the banana. There's really no pattern here. This would indicate no correlation. We're also looking, in this case, this is what they call the banana shape. It's kind of a curve here. You can see a curve, and so this would be a non-linear correlation. Now, I'm going to show you guys how to calculate the correlation coefficient. The correlation coefficient always assumes it's a straight line pattern. If it's a curved pattern like this, then you should not use the procedure we're going to use for the correlation coefficient. So, oh, I forgot I have a nice little video here. You guys probably aren't going to be able to hear it though. Now, let me show you guys a couple of websites here. This talks a little bit about the correlation coefficient, but the idea here is we're trying to determine how close the dots are together. So this would be an example of a positive correlation. It goes from low to high. If it went from high to low, that would be what we would call a negative correlation. So we're trying to see how spread out the dots are. So this is an example of a correlation coefficient of 0.03. It's hard to get exactly 0 unless you use kind of contrived data, but there's no real pattern going on here. So this is correlation coefficient of 0.03. You'd say, yeah, there's really no correlation going on here. We don't see any patterns, any straight lines, or even curved lines here. Okay, this one's a correlation coefficient of 0.28. You can kind of see that there's kind of parallel lines, you could say here. And then as we keep getting stronger, the dots get closer together. This is a correlation of 0.48, 0.72. We're starting to get some stronger patterns. This looks a lot like a hot dog. 0.89, now we're definitely looking at some stronger correlation. And then this is really strong correlation of 0.99. You'd almost wonder, in this case, if your data were faked. Now, I also want to show you another link here. So it's important to make sure that when you're looking at your data, that you always look at a scatter plot first, okay? So once again, this is perfect correlation. If you took a variable and correlated against itself, it would be a perfectly straight line. This is -1 over here, also a perfectly straight line. You can see, so this middle line here, you can see it doesn't really have to do a slope necessarily. You can see these all have a slightly different slope. They're all perfectly correlated. These are negatively correlated. So so this goes low to high, low to high, low to high, high to low, high to low, high to low. So the slant of the correlation doesn't really matter so long as we're looking at kind of the pattern of the dots here. So 0.8, this is what we would call this strong correlation. 0.4, we'd probably call this moderate correlation. 0, we would call no correlation. Now, we have to be a little bit careful, and of course that works in the negative direction as well. Negative 0.4, we'd call that probably moderate correlation. Negative 0.8, we'd call that strong, and then negative 1. Now, when we're calculating our correlation coefficient, that's why it's important to look at our pattern here and say, is there a pattern going on? In all of this bottom rows cases, you can see there are some patterns going on, but this is not a straight line, and so that's why we're getting a correlation coefficient of 0. Okay, so when we're looking at our scatter, so before we calculate our correlation coefficient, we should always look at the scatter plot first and make sure there really is no pattern. In this case, what we would say is this is a nonlinear correlation. These two look like they're kind of fake things, but these also indicate nonlinear correlations. This is something you would see in real life. This is a curve, you know, maybe a banana here. So this would be an example of a nonlinear correlation, and we would not want to use a straight line formula. This looks like two different populations here. Once again, this is why it's important to look at the correlation coefficient. If you just look at the correlation coefficient without looking at the scatter plot, you may incorrectly assume there's no correlation when in fact there is. And these are two other examples. So anyway, just wanted to show you. Now you probably want to know, how do we decide? I don't have that on here, but how do we decide strong, moderate, or weak correlation? Okay, so I'm going to show you something, and then tomorrow I'll break the rule a little bit. But so we use the letter R to represent the correlation coefficient. Usually it's a lowercase r, but that I capitalized it. So if the absolute value of R is in between 1 and 0.7, then we're going to call that strong. So this would be what we would be calling a strong correlation. If it's between 0.3 and 0.7, we'll call that moderate. And if your R is less than 0.3, we're going to call that weak. And I'm just using the absolute value there. So
what is the
negative
R?
point? Go ahead.
What is the R value?
Yeah, so that's what we call the correlation coefficient.
Oh, you'll show us how to calculate
And
that.
I'm going to show you how to do that in just a minute.
Okay.
I'm trying to start with the easy stuff, and then we'll go to the hard stuff. So if we have time, I'm going to show you a correlation video on Netflix, or maybe YouTube. I think it's on YouTube, so maybe I'll find it there. So the correlation coefficient describes the strength of the relationship of but it assumes that it's a straight line. Okay. This is known as the R value, and this is going to be a bummer because we need to be sure not to round, because if you round too early, we're going to introduce errors. So R equals 1 over n minus 1 times the sum of the product of x minus x bar over s sub x. Now let me times y minus y bar over s sub y. Let me just look at what's in this parentheses here for a second. Does that formula look really similar to another formula that we've introduced in chapter 3?
Yeah, it looks like the standard deviation formula.
Not the standard deviation formula, close though.
The sample mean.
It's the z-score formula, right? Basically, you've got your data minus your mean over your standard deviation. So basically, we need to find the z-score. This is your z-score for your x data. This is going to be your z-score for your y data. Okay? So I am going to let you guys, this formula will be on the test. And we're going to calculate the correlation coefficient. I wonder if this is going to copy. Oh, it copied. That was nice. Okay. So we're going to go back to this example of the golf club swing. Okay. So this looks like we can fit a straight line through here pretty well. So we're going to say that yes, linear correlation is a good idea. So now we're going to calculate the correlation coefficient. Okay. Now, some of you guys like to memorize steps. I'm going to copy these steps here. And then we're going to calculate this together. So I guarantee you, I will give you a problem like this on the exam. And you'll need to do this, okay? So as we look at, so I'm not going to give you the steps here. I will give you the formula. And if you want to memorize the steps, you're welcome to do that. But, you know, the first thing is we're looking here, X bar stands for your sample mean, S sub X stands for your sample standard deviation, N stands for your sample size. So the first thing we're going to want to do is we're going to find the mean. Oh boy, I didn't think about this. Okay. I'm going to try to make this easy for myself and for you. Let me just mention one thing about calculators. Most of you should have a statistical calculator by now. And your statistical calculator should be able to find the mean and the standard deviation really quickly and easily, okay? Since I made you guys figure out the standard deviation by hand on the last test, I'm not going to make you do that today. But that's going to require that you have a good calculator. So I know many of you have the TI-30, some of you have a Casio. Here's what so I do want you to find this correlation coefficient by hand. Most statistical calculators will find that also, but I want you to show me how to do this. So if you don't have a good calculator, or if you do have a good calculator and you don't know how to use it, here's what you're going to do. You're going to go to YouTube and you're going to say, how do I find the mean, or how do I find the standard deviation for my model of calculator in YouTube? And there will be a 5-minute tutorial that will show you how to do it. So I'm going to recommend that you do that. I'm not going to make you find the standard deviation by hand. I did that on the last test. I'm going to assume that you have a calculator that does that now. Excel is the greatest calculator ever because it'll create nice looking graphs and everything. But we're going to have to do the graphs by hand. So if we were in a regular class, I would give a test in Excel and I would expect that you would do it here. But in this case, we're going to do most of this by hand. Okay, so to find the mean, so we need to find the mean of each variable. So I'm going to find the mean, and the command in Excel is average. So the mean is 101.875 miles per hour. The mean distance is 266.75 yards. The standard deviation, std.s, because this is a sample. The standard deviation is 2.29 miles per hour and 7.74 yards, okay? So I'm going to assume that for your test, you're going to have a calculator that will find the mean and the standard deviation. You'll just have to enter in the data, okay? Just like that. You'll have X data, so this will be your X data, this will be your Y data. once again, this is the explanatory variable. This is your response variable. Now, let me take a minute to talk about that for a second. Sometimes these can be a little bit hard to determine. And to be honest, the correlation coefficient doesn't care what your X and what your Y is. It will give you the same value in either case. You only need to know that for the graph. So does the club head speed explain how far your ball goes, or does how far your ball goes explain your club head speed?
Your club head speed explains how far the ball goes.
Right. Okay. So we'll do another one if we have time. That may be a little bit harder, but yeah, generally speaking, in fact, just for fun, let me do something here. I'm going to copy this. I'm going to paste it here. I'm going to create a scatter plot really quickly. Insert scatter, boom. Oh, now usually, now that's interesting. Usually, if I use, now in this case, the way I've drawn this is going to be distance in yards. And this is club head speed. And then miles per hour. Okay. Now you'll notice, I should also mention here, correlation coefficient is unitless. It has no units. Okay. And in fact, you can compare wildly different stuff. Miles per hour versus your distance in yards, those aren't even close to the same units, but you can still compare them. I was hoping that this would have a different slope than this. So once again, in both cases, they're positively correlated. When you're calculating your correlation coefficient, it doesn't care, but you may see a different slope if you change your axes. So anyway, the way I drew it the first time was correct here, with your speed being the explanatory axis. Okay. All right, so we found the mean, we found the standard deviation. Now we need to find the z-scores. So I'm going to find the z-score for the speed. And I'm going to find the z-score for the distance. Okay. Now, when you guys are doing this on paper, it's important to remember that you use parentheses. So we're going to take, so the x minus x bar, I'm going to take the x data, I'm going to subtract the mean, and then I'm going to divide by the standard deviation. Okay. All right, so I'm going to copy that down. Now I'm going to do the same thing for the distance. I'm going to take the data minus the mean, the mean. I'm going to close my parenthesis. I'm going to divide by the standard deviation. Okay. And I'm going to copy that down. So for I copied one too many there. Okay. So I found the z-score for the x's. I found the z-score for the y's. My formula tells me I need to multiply these together. So I'm going to find the product. So that's going to be this times that. And I'm going to multiply or copy that down. Okay. On the product, what does this funny looking E look like or mean? What does it mean in statistics?
Sum of. So
Find the sum. So I'm going to find the sum of my products. Sum is 6.57. And the last thing I need to do is divide by n minus 1. Now my question to you all is, do I have 8 or do I have 16 in my sample size?
16.
So let's vote.
Eight.
Let's see if we can vote. We're going to do this here. Who says my sample size is 8? Who says my sample size is 16?
Could you post the Excel worksheet again?
I've already posted it. You want to look at it? Is that what you're
Like
saying?
after class.
Yeah,
just like
so I've
after
already
class, like you
posted
do
the
on
answers.
phone, just-
I've already posted the answers already. In fact, if you look here, there's a worksheet 4.1 worked out. It's already there.
Oh, okay. Thank you.
So, all right. So anyway, going back to my poll here, it looks like the majority of the class says 8. Yes, realize this is the same person being measured twice, right? It's the same person hitting the club 100 yards and going 257. So yes, your sample size is 8. So when we divide by n minus 1, you can think of that as n minus 1 pairs. Okay. So if my sample size is 8, I'm going to divide by 7. Okay. And that gives me 0.93866. Okay. Now, first question is that strong, moderate, or weak? So let's do another poll question here. Strong, moderate, or weak? Give me a thumbs up on which one you think it is. Okay. Looks like we're unanimous so far. All right. So, yes, it is strong. Strong because that's greater than 0.7. Okay. All right. So, let's see here. Okay. All right. Now, let me go back to my notes here for a second. Okay. Let's see here. Now, you've also heard the phrase correlation is not causality. And so let's talk about that. In this case, would it make sense that how far I swing the ball causes how far my ball goes? Would you agree that that would make sense?
In this case,
Okay.
yeah.
All right. So I'm going to show you a video here. And I think it's on YouTube. I guess I'll have to be the narrator here.
You can turn on captions.
Oh, maybe I could. Oh wow. This is a 1.5-minute movie. So I'll just kind of do this. This is from Freakonomics. By the way, so there's a podcast called Freakonomics, and it's the best statistics podcast out there. Well, that one on 538.com. So anyway, this is Captain Kangaroo. It's an old TV show. That's Captain Kangaroo right there. And he basically just said, did you know, boys and girls, that not everybody can run and jump and play because of a thing called polio. So polio was this horrible disease, and they didn't know what caused it. In fact, I'll ask you guys here in a minute what caused it. But they were trying to figure out what caused polio, And so there was a line of research that said it must be ice cream. Ice cream causes polio. And so there were some people that said, oh, we got to quit eating ice cream because it's causing polio. And the reason why they thought that was because they created a correlation model here. And you can see these are number of polio cases that happen in the summer. And I'm going to pause this right now. And so this is ice cream sales, okay? Now, once again, this is an example of a nonlinear correlation, but you can see it does appear that there's a strong correlation that the more ice cream that we eat, excuse me, that's the green line, the more ice cream we eat, the more polio cases we have, okay? So the question is, in fact, maybe I'll just stop there. The question is, so there were a lot of people that thought ice cream caused polio. Now, do you guys know what causes polio?
That way. Wasn't it something to do with the cow, like the dairy products? Something from the cows, like they got boils or something, from the something like that. I can't remember.
Oh.
Sure.
It was spread through a virus.
It was spread through a virus, just like coronavirus, right? Do you guys know where this virus was found? It was found in lakes and streams, okay? Well, so guess what happens? In the summertime, people go swimming, and they swim in infected lakes and ponds. They also happen to eat a lot of ice cream in the summer, okay? And so there is a correlation going on. This graph makes it appear like ice cream is causing polio. In fact, there is a correlation, but the lurking variable is it's summertime, okay? And people swim and eat a lot more ice cream in the summertime than they do in the cold winter. And so the interesting thing about correlation is, even though ice cream does not cause polio, we could actually use ice cream sales to predict the number of polio sales. And so this is a perfect example of correlation doesn't cause, correlation is not causality. Ice cream does not cause polio, but you could actually use the number of ice cream sold to predict the number of cases of polio that you would have. And so once again, this is a perfect example of correlation and causality. Let's see here. Now, just for fun, let me just show you, this is an example of a nonlinear correlation. I'm going to go ahead, I'm going to create a scatter plot. And does that look like a straight line to you all?
No.
No. Okay. Let me back up here a second here. I am still going to practice with you guys. In fact, let me see if I can copy this formula here. And I'm going to have you guys help me calculate the correlation coefficient here. And we're going to figure out what it is in this case, okay? So this is a perfect example of data we should not use this equation on, because I mean, it kind of looks like a triangle or maybe a curve here. But this is where this equation sort of fails on this type of data, okay? So let's see here. Jed, can you help me figure out what's the first thing I should find when I'm looking for the correlation coefficient?
I think the first thing you should find is the mean.
Mean? What's the second thing?
Standard deviation.
Standard deviation. And you all are going to figure out how to figure out the mean and the standard deviation today, right? Okay, so I'm going to cheat here. We're going to find the mean. So 30, and the standard deviation 31, or sorry, means 30 and 31, and the standard deviation, and this is a sample. So I'm going to use this number, that one, okay? Okay, so we found the first two steps. Third step, Whitney. Oh, I thought it said Whitney Bear there for a second. It's Baker, Whitney Baker. So what do I do with my mean and my standard deviation?
You're going to basically find the z-score.
Z-score for the speed,
And
and
for
the Z-score for the
miles
miles
per
per gallon. Okay. So by the way, I guess I should make a question here. Do you think speed of your car affects your miles per gallon?
Yeah.
Yes, probably would. Okay. Okay, so it looks like we kind of have a sweet spot. According to this graph, if you go 30 miles an hour, that's the best miles per gallon. And if you go faster or slower, you're going to, it's not going to be as good in either case. All right, so Z-scores. Whitney, can you help me tell me what to type for these Z-scores?
So you'll do the data point for speed, so this would be 20.
20
Mhm.
minus
And you would subtract the 30 mean,
30.
and then
Okay.
you divide all of that by the standard deviation of the 7.9, yada yada.
Divided by the 7.9, right. Okay, now here's the one thing that I do want to emphasize here. The biggest mistake I see on the test, and normally I let you guys turn in your spreadsheets, but I won't be able to do that this time. The biggest mistake is people who don't use parentheses. They use all the right numbers, they don't use parentheses, and in fact, maybe we'll show you the difference in this case. What happens if you don't, but I'm going to do it right now. And then, okay, so we'll copy that down. Then we're going to ask Jonathan, can you tell me how to find the Z-score for the miles per gallon?
Yes, so for miles per gallon, you're going to take the 30 minus the average, divided by
30
the
minus 31. Now you meant to say mean, right? We don't use the
Yes,
A
of
word in
course.
this class.
Average
Right?
is not a real thing. Yes, by the mean. And then you make sure that's in parentheses. You're going to divide that by the standard deviation,
Standard
Y,
deviation. Okay.
and then copy it down the column, obviously.
Then we're going to copy it down, and it's nice when you're using Excel to do these. Okay. What is the next step, Alexander? According to my equation here.
Yes, sir.
What's the next step?
You just got the Z MPG. You want to multiply the Z scores together.
Okay, find the product of the Z's. Okay. Now, the other thing I do want to mention is please set yours up like this so that when I look, obviously I won't be able to see all your calculations, but hopefully they will match. And all right, so did I do that right? Yeah, I did. Okay, so we're going to find the product of my Z scores here. What's the next step, Rayleigh?
You're gonna find the sum of that number.
And the sum. Okay, the sum of my
The
products. In this case, I got a big fat 0, which probably should make me nervous, but in this case, it's a special case and it actually is 0. Then what is the next step, Caitlin?
You're going to divide by n minus 1.
And what's my n in this case?
5.
And it's 5,
Also,
so we're going to divide by 4 in this case. So 0 divided by 4 is still 0. That is your correlation coefficient. Okay. And that actually is the correct answer. Now, couple things that I want to point out here. So let me just mention here, when I give you a problem like this on the test, and notice I said when, not if. When I give you this, I want to see all of these calculations here, okay? And if you can try to set it up similar to this, that would be awesome. Also, if your calculator can find the mean and the standard deviation, it can also find the correlation coefficient. So you are welcome to check your answer. This is how you would do it in Excel. And it will give you a 0 as well. But if that's the only thing you do, guess how many points you're going to get on the test?
0.
Big fat 0. I want to see all of these calculations that we've got here. Actually, I want to see the mean too. So I want to see all of this. So I want you to find this by hand. Now, I told you I was going to show you what happens. So 0 is the correct answer in this case. And also, is linear correlation a good idea? Not a good idea. Okay. Because normally when we get a correlation of 0, we say that there's no correlation. Is there correlation in this case?
Yeah.
Yes,
Yep.
there is. It's a nonlinear correlation. So this equation doesn't work when it's nonlinear. Doesn't work well, okay? I do want to just show you guys really quickly. If I get rid of the parentheses in the numerator here, I'm going to do this for both things here. And I'm going to copy these formulas down. Okay. Notice my sum is 1666 and I got a number of 416. Okay. Can you look at that and know clearly that that number is wrong? Why is 416 clearly a wrong number?
Because it's not.
Going to be -1 and 1.
I didn't hear whoever said that. It was very soft.
I just said because we know our correlation is going to be between -1 and 1.
-1 and +1. That's correct. Okay. So if you get a value such as 416, you'll still get more credit for doing this. Now, and this is the case where we use all of the right answers, but we didn't put parentheses in, and so that really messed up the problem badly. Anyway, I just wanted to point that out. So parentheses makes a huge difference. So I'm curious what happens here. Sometimes we're going to take out the parentheses in both of these. So that once again, we're using all of the right values here. Yeah, we're getting 15,000. So clearly you should know that you've done something wrong. So hopefully you'll have enough time to figure out your mistake. But all right. So any questions on correlation coefficients and scatter plots? Okay. Well, I usually go long, and I'm going to give you back a minute or two for today. So quiz tomorrow will be on 4.1. Now, just remember, I'm probably going to give you a multiple choice quiz because those are super easy to grade. For the test, you're going to have to draw a scatter plot by hand, and you're going to have to find the correlation coefficient by hand. So that probably will not be on the quiz. So just remember, the test will be a lot harder than the quiz I'm going to give you. So any questions before I let you guys go?
Yeah, I have a question really quick.
Okay,
So
go ahead.
if we do this scatter plot and we can see that it's obviously not linear, we're still always going to do that formula to find the correlation coefficient.
Oh, that's a really good question on the test. Yes. So I would like you to say, yes, it's not linear. Correlation coefficient's a bad idea, but on the test, I'm still probably going to make you do the correlation coefficient anyway.
Okay.
So, but yeah, you would know that it was a bad idea.
Okay.
Any other questions? Okay. I'll let you guys go. We'll see y'all tomorrow.
Thank you.
Thank you.
you.
Thank you.